point slope form. This lesson's all about how to use point slope form in all the various ways. What is point slope form first of all? So it's a linear equation in the form of y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is the point. Much like slope-intercept form, y equals mx plus b, how from the very jump you know, oh, that's my slope, that's my y-intercept. With point slope form, same idea, like, oh, there's my slope, and then here is my point. So where slope-intercept form tells you where the slope and the y-intercept are really easily, point slope form gives you the slope and a point really easily. But the real benefit is going the opposite way. If you have a point and a slope, you can plug it into this form really easily. So for me, the real benefit of this thing, I always call this like the equation maker. It's easy to make an equation. If you need to make an equation, put in a point slope form is the easiest way to do it by far. Slope-intercept form, easiest way to graph. If you want to make an equation though, point slope form is the easiest way to do that. Here's slope. We know slope is rise over run, or you can use our equation here, y2 minus y1 over x2 minus x1. Speaking of that equation, if you're wondering, wait, where do we get this new equation from? It comes from the slope equation. If you look at this equation here and you multiply both sides, like you try to solve for the top here, get rid of this denominator, multiply both sides by x2 minus x1. These would cancel out, and look what you have. You have m times x2 minus x1 over y2 minus y1. And then if you just change the x2 to x and the y2 to y, you have your point slope form. Y minus y1 equals m times x minus x1. That's where it comes from. You just get the slope equation and multiply. And wait, let's use it. Let's use our point slope form. Point slope form, when I was in high school, I hated it. Hated it. I was an idiot because it's the best form. It's my favorite form now. So I hope you find the same joy that I find in it now. This is the beauty of it. Oh, it's already written right here. Anyway, write the equation of a line that has a slope of 3 and it passes through the point of 5, negative 2. Doing that in slope-intercept form is not a lot of work, but it's work. Doing that in point slope form, done. Easy. There's my slope. That goes here. Here's my x1, my y1. That goes here and here. Simplify a little bit. Y plus 2, write the two negatives, make a positive. 3x minus 5. And you are done. They said write an equation. You did it. Done. Now, sometimes they might say put in slope-intercept form. We'll do one of those. But for now, if all it says write equation, you are done. That's how easy it is. Look over here. It's a fraction. Oh, we'd hate that in slope-intercept form. But if this says write an equation, put in point slope form. My slope is 1/2. My point, x1, y1, is negative 6 and 1. Rewrite it. Y minus 1 equals 1/2. X plus 6, again, double negative. And there you go. Look how easy that is. I love point slope form. It makes writing equations so easy. Then you're like, okay, what if they give me 2 points instead of just 1? Well, it's almost just as easy. Step 1, find the slope. Remember the way you find slope? The easiest way is to use the slope equation, y2 minus y1 over x2 minus x1. And then once you find the slope, you just put in point slope form because you have a point already, and now you found the slope, right? You have 2 points. You have an abundance of points. You just need the slope. So find the slope, pick any point, it does not matter which one, and plug in for your point, and you're done. Unless it says something like converts to slope-intercept form. And then you go a little bit further, but we'll get there. So let's do it for this one. I want to write an equation for this one, so I got to find my slope first. Again, it does not matter. Pick one of them as x1 and y1, and pick the other one as x2 and y2. Let's find our slope. So y2, which is negative 2, minus y1, which is 2, over x2, 5, minus x1, 3. At the top here, remember they're both negative, so you just add them. I get negative 4. 5 minus 3 is 2, which simplifies to negative 2, like that. So I have my slope. I'm going to pick a point to plug into here. Well, they're asking for x1, y1. I could use x2, y2, but honestly, just use either one. That's fine. So I'm going to use these. And I'm going to get y minus, this is going to be 2, and that's going to be 3, and this is negative 2. So y minus 2 equals negative 2, x minus 3. Now, if it says convert to slope-intercept form, let's remind ourselves, slope-intercept form looks like y equals mx plus b. So we want to get y by itself. So what we're going to do is distribute this and then add the negative 2 over. So let's get started. Let's distribute that. Y minus 2 equals negative 2x plus 6. Negative 2 times negative 3 is a positive 6. Now I want to get y by itself, so we're going to add 2 over. So y equals negative 2x plus 8. Now you might be wondering, what if I use, instead of using 3, 2, I use 5 and negative 2? You would have the exact same answer. So let's do this here. Instead of using these, what if I use 5 and negative 2 for my point? I'm going to do it over here. So we would have this as our equation originally, like that. This looks very different, right? But if you put it in slope-intercept form, you can get the exact same answer. So let's distribute negative 2x plus 10, y plus 2. I'm trying to get y by itself, so let's subtract 2 from both sides. And we get y equals negative 2x. 10 minus 2 is 8. So you get the exact same answer. So that's why a lot of times when you do have to write an equation, a lot of times they'll ask you to put in slope-intercept form, because that way you have the same answer. Where in this case, you could have got either one of these two, which are the same, like mathematically, But as a teacher, teachers are great at when they're like identical. But anyway, either one does work. You just have to watch out if they do ask you to put slope-intercept form, do simplify and put slope-intercept form. Okay, so that's how you write an equation of 2 points. At 2 points, find the slope first, then you plug into my favorite equation, point slope form. Then if you have to, simplify to get slope-intercept form. Next up, how do you graph with point slope form? It's actually not that bad. So what we want to find, if they give us it in point slope form, is find those two things. Find the slope and find the point. So in this one, the slope, remember our point slope form is this. There we go. Our slope is a coefficient of the parentheses. So right here is our slope. So our slope here is going to be 2. I'll put over 1 because it's a run. So we're going to go up 2 over 1. But where do I start? Now, we like to start on the y-intercept. That's true. But in this case, we can also start at any point. If I have a point, attach the slope to it, and you're off and running. So what's the slope here? Keep in mind, when you have this, the point is x1, y1. I bring that up because right here, right, it's a negative x, it's a negative y. It's like the opposite. So here, our x point's not -3, it's +3. And here, it's not +1, it's -1. When you plug these in, if you plug this into the formula, the signs change because of the negatives here. So that's one thing that's a little tricky. You have to go, okay, what's the point here? The point's going to be 3 and -1. Once you have that down though, start here, just like how you would start in your y-intercept. Start at the point 3, -1. So 3, -1 right there. And then from this point, follow the slope. So we're going to go up 2 and write 1 from our point, from our starting point. So we're going to go up 2 and then over 1. Just do another one just to make sure. And if you keep on following, if you have a nice graph, you actually could find the y-intercept. If I was doing this like a little nicer, you actually could find the y-intercept. It should be like right here at -10, I think. So if you have a nice graph, if you do it nice enough, you actually could find the y-intercept. It's kind of going backwards. Like, let's graph another one of these just to be sure we know what you're doing. So if I was doing this right, we got to find the slope and the point. The slope would be -2/3. Fractions don't scare me here because this is rise over run. We're going to go down 2 and then right 3. Nice. What's the point? Keep in mind, it's the opposite of this, right? So it's like you're solving it. So it's going to be -1 and +3. So that's our point, -1, +3. That's where you want to start, -1 and +3. And then from that point, we're going to follow our slopes. We're going to go down 2 and right 3. So down 2, right 3. Just like that. Connect them. I was waiting for it to straighten out, and it gets done like that. So that's how you graph in point slope form. So not that bad. If you have the slope already, you just got to find your point and then connect them. Okay, let's finish off with the linear application problem. An event facility has a banquet hall that can hold up to 250 people. The price for a party includes the cost of the room rental plus the cost of a meal for each guest. Marissa is planning an event for 75 people. She has budgeted $1,200 for the party. Will it be enough? So this is the information they gave us. We have a table here. You always want to know what the X and Y axis are. So X is the number of guests. We have 50 guests, it costs $725. 100 guests, it costs $135, and so on. First question is, which form of linear equation is more useful for this example? Like, should we do point slope form or slope-intercept form? Now, there's no y-intercept. So slope-intercept form is, well, helpful is not the most helpful. We're going to do point slope form. So point slope, because there's no y-intercept known. We don't know what the y-intercept is. It's probably the easiest way to say that. Okay, what does it represent? Now remember, to find the slope, anytime you want to find the slope, you need 2 points. Anytime you want to find slope, no matter what it is, you need 2 points. Unless you have an equation in slope-intercept form. But anyway, in general, you need 2 points. So wherever points at, they're right here. All these pictures are points. We have 50 with 725. We have 100 guests with 1325. These are all points we can use. Let's do the first two. We'll do 50 with 725, and then we'll do 100 with 1325. And the way you find the slope is we're going to use our slope equation. M equals y2 minus y1 over x2 minus x1. And again, it does not matter which one's which. We'll say this is x2 and y2, and this will be x1 and y1. So this will be 1325 minus 725 over 100 minus 50. And we get 600 over 50, which is also known as 12. Now, so that my slope is 12. Now, again, what does the slope represent? If you remember from last time, the trick to doing this is, just like how you do slope in general, make it a fraction, rise over run, and the top is y over x. Slope is a change of y over the change of x, rise over run. So what is our y? What's the units? Y is cost, and then what's our units for x? It's a number of guests. And my trick is always, the divide line is per. So we're doing $12 per guest. So that's the cost of the meals. Each meal is going to cost $12 per guest. That's what's going on. So that's how you interpret slope. It's always y per x, y over x. So what's our y? $12 here, and then for each one guest. So each meal costs $12. Next, use point slope form to find the cost of the event for 75 guests. So how are we going to do that? Well, points of form is this: y minus y1 equals mx minus x1. Our m we just figured out it's 12. How about our x1, y1? Now remember, we have all these points. Use them. So we'll use 50 and 75. Again, I'm just using that because that's the first one I see. It does not matter which point you use. So simplify this equation a bit. Y minus 725 equals 12, x minus 50. And what do they want us to find? What's the cost for 75 guests? So what is guess? So remember up here, our cost is y, our number of guests is x. So we're going to plug in 75 for x. So guest is x, so let's plug it in. And we just have to simplify. So y minus 725 equals 12, 75 minus 50. We can simplify this up a bit. So y minus 725 equals 12 times 25. That's going to be 300. So minus 75, 25. Add that to both sides. We're solving for y. And we have y equals $1,025. So that's the cost for 75 guests. How much does she budget? $1,200. So she's going to make it. She has budgeted the right amount. The total cost is $1,025. So she will have enough money with some to spare. So that's the lesson.